This video covers the laws of logarithms. There are 3 log rules and then 2 values that are useful to remember. And we've discussed those 2 before. You've seen them previously on one of the other videos where we looked at the graphs, but we'll state them here all together. So the things that we're going to state now, you should remember them. Rule number 1. Log to the base a of x plus log to the base a of y is equal to log to the base a of x times y. So when we're adding 2 logs together, basically we multiply the powers. So we multiply the x and the y, the power parts together. This is only true though if the bases are the same. So you'll see that both bases are a on the left hand side and the base is also a on the right hand side. Rule number 2. Log to the base a of x minus log to the base a of y is equal to log to the base a of x divided by y. So when we take away logs, we divide the powers. So we divide x by y. And again, the bases are all a. Rule number 3. Log to the base a of x to the power n can be written as n times log to the base a of x. So here we can go in both directions, which is what the arrow in between implies. If we have a log to the base of a power and that power has been raised to another power, that top power can come to the front. So the n in this case can move from the front and move back upwards. So we can do it in both directions. So in all cases, the base must be the same. In all rules, the bases must be the same. Right, before we look at some examples of that, I will give you the 2 values that are useful to remember. So they are log to the base a of a is equal to 1 and log to the base a of 1 is equal to 0. And we saw that from the graph. So we saw that we had the points a1 and 1, 0 on our graph, and that's what those 2 rules are telling us. So it's helpful to remember those when it comes to solving these equations and evaluating answers for these equations. Now we will look at some examples where we are using the log rules to simplify or evaluate log equations. Example 1. Simplify log to the base 4 of x plus log to the base 4 of 2. Right, so you'll see that the base is the same in both of these. They're both 4. So that means we can use rule number 1. So we're going to use rule number 1. We're adding, so it's rule number 1. So we're adding the logs, which means we multiply the powers. So the answer will be log to the base 4 of 8 times 2, which is log to the base 4 of 16. Now, you might have thought at that stage that you would stop there, but actually we can use rule number 3 if we think about 16 as being equal to 4 squared. So often we don't go backwards with taking the square root of something to get us to think of it as being a power of a number, but this is what we're having to do here. So we're thinking that 16 can actually be written as 4 squared. So the square root of 16 is 4, so therefore 4 squared. So if we rewrite that as log to the base 4 of 4 squared, then hopefully you can see that we can now use that rule number 3 to bring the power 2 to the front. So we would have 2 log to the base 4 of 4. And then the final rule that we're using, well, it's not really a rule, it was one of those values on the last slide, log to to the base 4 of 4 is equal to 1. So we would have 2 times 1, which is 2. So the answer to this example is 2. Example 2. Simplify. Log to the base 3 of 54 minus log to the base 3 of 2. So this time our bases are both 3 and we have a subtraction between the logs, so we are using rule number 2. So we would have log to the base 3 and we want to do 54 divided by 2. So that gives us log to the base 3 of 27. And now at this stage, we're now trying to think, can we take that any further? Is there anything that we can do with 27 to write it in terms of a number with a power? And again, 27 is 3 cubed. So you do need to be familiar with your square numbers and your cube numbers here. So we can write that as log to the base 3 of 3 cubed. And use rule number 2 to bring the highest power 3 to the front. Well, a lot of 3's in this question. So we've got 3 times log to the base 3 of 3, and log to the base 3 of 3 is equal to 1. So we again have 3 times 1, which is 3. Example 3. Solve the logarithmic equation. And the equation is log to the base 3 of x is equal to log to the base 3 of 16. It's not a very good 3, sorry there. Minus log to the base 3 of 4. And it's also given a little bit of information. It says for x greater than 0. We don't need to concern ourselves too much with that. Sorry, I'll just tidy that up. Okay. Right, so the first thing we're going to do is we're going to resolve the right-hand side of the equation. The left-hand side has an x, so we're going to leave that there. So the right-hand side of the equation, we can use rule number 2 for that because it is a subtraction. So we'll have log to the base 3 of x equal to log to the base 3 of 16 divided by 4. So we have log to the base 3 of x equal to log to the base 3 of 4. Now at this stage, I want to point out that the log to the base a of x equal to log to the base a of y is equal to, or becomes, x equal to y. So it's almost like the logs just cancel out there. You have the same log on both sides. So as long as the bases are the same, we can cancel out the logs and we're left with x equal to 4 in our case. One final example. Example 4. Solve the logarithmic equation log to the base 3 of x plus 1 minus log to the base 3 of x plus 1 squared equal to log to the base 3 of 4, and again x is greater than 0. Okay, so this one looks substantially more complex to the other example that we did, example 3, but we're just going to carry on by thinking about the rules that we know, where can we use them, and then solving for x. Right, so first of all, we are going to deal with this 3. We cannot use rule 1 and rule 2 if we have a number in front of the log. So we need to bring this 3 up and make it a power. So that will be log to the base 3 of x plus 1 cubed minus log to the base 3 of x plus 1 squared equal to log to the base 3 of 4. Now at this stage we can use rule number 2 because we're taking away logs on this left hand side. So log to the base 3 of x plus 1 cubed over x plus 1 squared equal to log to the base 3 of 4. And hopefully, thinking back to algebraic fractions, you can realise that the brackets can cancel out here on the left hand side. So we have 3 of the brackets on the top and 2 on the bottom, so we can cancel out 2. So we're left with log to the base 3 of x plus 1 equal to log to the base 3 of 4. And now we're at the stage we were in example 3, the stage one step from the end, where we could cancel out the logs because they both have the same base. So we're just going to be left with x plus 1 equal to 4. And using transposition, if we take away 1, we have x equal to 3. And that's our final answer. So those are the 3 log rules plus a couple of key values that it's handy to remember.